What's up, mathletes? It's Mr. Nolde here, your personal math coach. Today I'm coming at you with synthetic division. So here's a quick review of polynomial long division, and then I'm going to do the same exact problem using synthetic division, and you'll see that we get the same answer. So for starters, I'm going to see x goes into 3x to the fourth, 3x cubed times. So I'm going to go ahead and write 3x cubed up here, and then I'm going to multiply 3x to the fourth plus 6x cubed. So those values, again, remember, are coming from 3x cubed times x is 3x to the fourth, and 3x cubed times 2 is 6x cubed. Then we want to subtract. So subtract. And we have to remember that we are subtracting both of these terms, both the 3x to the fourth from 3x to the fourth and the 6x cubed from 7x cubed. So let's go ahead and do that. I get 1x cubed when I do 7. Well, that's a bad cube. When I do 7 minus 3. Then I drop, looks like I was missing a value here. Then I'll drop my 3x squared. And again, I'll say leading term, leading term. X goes into x cubed how many times? Well, x squared times, because x squared times x is x cubed, and x squared times 2 is 2x cubed. So I'll write that in. Then I'll subtract. Again, remembering that we are subtracting both this term and this term. So I put a minus in front of both of them. So x cubed minus x cubed. Oops, I hit an erase there. I meant to hit a point. Let me jot that back down for you. So x cubed minus x cubed, that is a 0. 3x squared minus 2x squared, that's 1x squared. So, or sorry, I said x squared, it's cubed. It's cubed. No, it is squared. Look at that. I jotted that piece down incorrectly. Let me quick fix that for us. That's a square. Because we have to add and subtract like terms, of course. So go ahead. 3x squared minus 2x squared, that's 1x squared. Goes right here. Drop down the final term, minus x. So minus x, let's see, how many times will x go into x squared? Well, it goes in x times. The reason I know this is because I have x times x will give me an x squared here. So that's what I wanted to have happen. I want these two to be the same, and then distribute the x on the 2, and I get 2x. So that's 2x. Then I'm going to go ahead and subtract again. Let me put in my little trick here, minus both of these, and then, let's see. Anything minus itself is 0, and negative x minus 2x is negative 3x. We have one more term to bring down here, and that's our minus 4. And then we say, all right, x, this x, goes into negative 3x, negative 3 times. And then I'm going to distribute this minus 3. I'm going to distribute this minus 3 on x plus 2 and write it here. So that gives me negative 3x minus 6. Okay. So anything minus itself is 0. Let me go ahead and put in my little minus signs here. And so when I subtract negative 3x minus negative 3x, I get a 0. Negative 4 minus a negative 6, that gives us a positive 2. And that is, friends, our remainder. And I will put that in the color blue. So plus 2 over the dividend of x minus, or not x minus, x plus 2. I said minus, but I wrote plus. So this is the quotient of this problem up here that we started with. All right, so this is the quotient right here. Boy, that's a lot of work, don't you think? Remembering all these signs of everything when you're multiplying, dividing, subtracting, it can get very challenging. And it's not that it's difficult, but it's just very easy to make a mistake. We've developed this thing called synthetic division. So let's look at the same example using synthetic division. What synthetic division does is it eliminates all of the variable parts. It only lists the most important parts to our final answer, and that happens to be, in this case, the coefficients in descending order of the variable. So I have a 3x to the fourth, that's my 3. 7x cubed, there's my 7. 3x squared, there's our 3. Negative 1x gets a negative 1 here, and constant of negative 4 gets a negative 4 here. Now the same thing applies as in the previous lesson on long division. If I am missing a term in here in descending order, 4, 3, 2, 1, 0, I have to put a placeholder in here. Okay, I did not need to do that here, so I'm not going to worry about it. So I want to use synthetic division to divide this out. So here is how we do it. We drop the 3 first, and then I use a negative 2 here as my divisor. Why am I using a negative 2 instead of a positive 2? The only reason for doing that is so that we can add these things, because that makes our lives a little bit easier. So the negative 2, another way you could think about it is, if this divided into this evenly, then x plus 2 equals 0 would be a divisor, making x equal to negative 2. That's another way of thinking of it, but the real reason is because we're changing the signs of these numbers that are going to go here so that we can add instead of subtract the way we do with the polynomial long division. So here's the first step. We take that minus 2 that comes from here, minus 2 times 3. Well, that equals negative 6. Where do we put that? Right here. And then we add. We don't subtract, we add. Because remember, I changed this from a 2 to a negative 2. So I add those. This is going to make life easier. Then I'm going to multiply negative 2 times 1 to get negative 2. And then I'm going to add 3, and negative 2 is 1. Then I have negative 2. Negative 2 times 1 is negative 2. So I'll write that in. And then I'll add negative 3. And then negative 2 times negative 3 is positive 6. And then I'm going to add these down, and that gives me a 2. So what that tells me is I started with an x to the fourth, and I divided by a linear, x to the 1. So this final expression is going to be a quartic divided by a linear is going to leave us with a cubic. So 3x cubed plus 1x squared plus 1x minus 3 plus the remainder of 2 all over the initial divisor of x plus 2. And there we have an example with synthetic division. Now, there is one caveat to synthetic division, and that is I have to be dividing by a linear term. I cannot use this process if I'm dividing by a quadratic or a cubic or anything else. It has to be linear, but as you'll find out moving forward in pre-calculus, there's a reason for that. So anyway, this has to be a linear. So let's look back now. Here was our solution using synthetic division. And previous slide, this was our solution using polynomial long division. So not sure, most people, myself included, and a lot of my students, would rather do this, right, this process, because it's much easier, multiply and add, than, go back, than this process. It's very easy to make a mistake if you're not used to doing this. I myself will make mistakes on this to this day, so that's why I'm always double checking myself. But like I said, remember that if you're going to use this process, you have to have a linear divisor. All right, so that's all I have on synthetic division. So stay tuned for my next lesson. So there you go. There's a short example on how to use synthetic division to get the same answer that you would get using polynomial long division. Synthetic division is just a little bit easier. So we're going to have many future videos that use synthetic division during the course of solving a problem that we're looking at. So hopefully you've gotten value from this. If you have, go ahead and hit the like button. Also, let me know down in the comments below, did you like the white screen or do you prefer the black screen? Anyway, I was just trying something different just to try to mix it up. So anyway, thanks a lot. Appreciate you watching till the end. Please go ahead and subscribe. That way you'll never miss a single video. Until next time, This is Noldy signing out.